Bittensor is really changing the ground rules or the playbook for how AI is incentivized itself, and also in terms of how it's governed and accessed. And additionally, in terms of how it improves and how it gets better. It's really taking a page from the history books of how all technology has really been developed.
I feel like Bittensor is where the internet was in 1991 in some sense, where it was just a bunch of programmers using the internet because there wasn't a web yet. So you kind of had to be a programmer to use the internet. There's not really a sense that, oh, we need to make a nice front end.
I believe, this is a really huge statement, but I think Bittensor is more disruptive in terms of the commoditization of technology than open source.
So Joe, I wanted to ask you some real world use cases of, let's say I'm an AI entrepreneur and I want to create something on Bittensor, and maybe we could brainstorm how I can do this. I'm going to pitch you an idea like an entrepreneur would, and then let's see if Bittensor would be a good fit for me.
Okay, let's go.
So let's say I want to create an AI model that the biggest customer are going to be doctors in an ER. So doctors in an ER have a problem. Patients come in, there's blood everywhere, there's all sorts of things happening. There's very rough text or audio data based on what the ambulance said while they were coming in. And so I need to figure out very quickly, within seconds, what to do with this patient. And sometimes I'm right and sometimes I'm wrong. So what if I have a labeled data set of videos and also some text or audio patient data of patients coming into an ER, and I have it's labeled with the correct diagnostics. These are like old videos. That's my data set. Now I want to train an AI model so that when I have video of a new patient coming in, it knows what to do.
So the cool thing about Bittensor is that it's an infrastructure sort of platform or protocol. In the same way that Bitcoin incentivizes people to run these computers that solve a cryptographic hash, it produces this really secure network that sort of like is a money alternative or a fiat alternative. It's a store of value, and you can also reprice things in Bitcoin. The end users of Bitcoin, like normal people experiencing hyperinflation in Argentina or Venezuela, right, or El Salvador or wherever the currency is being inflated away, which is actually most countries, they don't need to know about how Bitcoin does SHA-256 hashing. They just need to know that Bitcoin is the answer to their problem, right? And so the doctor in the ER, by the same token, no pun intended on token, we use this word token a lot, is going to be using AI tokens from an AI model trained on very sensitive and important patient data that some startup will probably train models for. And if we look at the top few Bittensor subnets, that's what they do. So Shoots provides models for people to use, and Targon is very similar. Gradients allows you to train models. If you go to the websites of these subnets, many of them are open source projects, but the websites of these subnets are really well designed, and there's a front end. So the doctor may not directly go to Shoots to use DeepSeek or to use one of these AI models that Shoots hosts. He might not directly use Mistral, right? But a developer, a startup, and we can look at the Targon subnet 4. Targon is very similar. They let you use these AI models and you can experiment with them. So for example, there's a playground, and the new hotness in open weights models is Kimi K2. So Kimi K2 is amazing.
So Targon is a subnet that takes both video and text and
Yes.
a question and can make an inference. But what if Targon has
Correct.
not already been trained on 1,000 videos of 1,000 ER videos of patients entering the room? Like I want to train the model.
Exactly. So, I'm just giving you an example of inference. So Targon serves output tokens from a lot of the top models, and they host the models for you. So you can interact with the model here. If you wanted to train a model, you would use something like gradients,
Yes.
which is Subnet 56. And they also have a really nice front end where you can go and train one of these open models available on the internet. You can upload a data set. So you can say, look, I'm going to give my data set to gradients and
And
create
will it
a
store
text
the
model.
data set?
No, you have full control over where that data is stored. So for example, you would select a base model. You'd say, okay, I want to use R1 7dB. And then you'd say, I want to select a data set. Some of the data sets are predefined to specific training data. So it could be video, it could be Arabic hate speech, it could be sports data, anything. In the same way that there's a lot of models, there's a lot of data sets. So models are trained on huge amounts of data sets. So you could use one of these available data sets, or you can build a custom data set for your model and provide a data set there. So this platform allows infrastructure to be built for developers to then provide products. Bittensor does not itself directly build products for the doctor in the ER. It builds protocols that allow the commodities that the products depend on, the core ingredients of the products, right? Like you're making a great meal, you've got to go and, get all these ingredients. Bittensor makes those ingredients abundant commodities, abundantly available for everybody, right? So, there's a time in history when salt was not an abundant commodity. There was a time in history when rice was not an abundant commodity. In fact, the Japanese government in the early sort of economic period of Japan's development primarily produced in exchange for rice. It was a rice commodities economy. So tens of billions of dollars equivalent in rice commodities dominated Japan's economy. So I think if you look at the world that we're living in now with all of these AI commodities that in some cases they're not really commodities, they're scarcity, proprietary products that Google and Microsoft and a small handful of companies are providing. Bittensor enables every one of these scarce digital products to be abundant, decentralized commodities, basically.
So in this case, the scarce commodity, the scarce resource that I have is I have a data set of patients coming into the ER that I've labeled, oh, this guy has a broken leg, this guy has a bullet wound, this guy is having a stroke, and so on. So now I put this data set on, and let's say I'm not creating my own subnet. I'm using subnets that already exist on Bittensor. I can maybe store the subnet on, is it Hippias is the sort of decentralized storage subnet, and then I could point that at something like gradients and say, okay, here's my data set. Here's the training set. Here's a set that's I want to see. The gradients basically can train on the data set that I give it and make an AI model. Is that roughly correct?
That's correct. And some of these subnets provide a higher level sort of platform service that actually itself is a combination of a lot of different technologies like storage, computation, memory, data parsing, data cleansing, data integration, right? So
Right.
in terms of developing applications, what most mainstream people assume is that there's a team that's just building all of this magical technology and they're delivering it to you. The reality is that team is depending on 20 other technologies that someone else built. And then what they're doing is just assembling them together and giving you a final product, right? So the example of how this works in the early days of the internet, Google, Amazon, Facebook, is that they would use open source technologies and compile together and sort of compose and weave together all of these open source technologies. And then they would build Facebook, or they would build Google, or they would build, these big internet platforms, Amazon. And the things that Amazon would compile together, if you look at the early job descriptions of the engineers that Jeff Bezos was hiring, they were, C, assembly, C++, MySQL, programmers. experience with Linux. Jeff did not have to write Linux, MySQL, C++, right? Like C. He didn't have to write those technologies. Those were built by thousands of people contributing over the internet to a permissionless, sort of set of technologies that, allow the internet to be created. And so what newer startups are doing is they're also still doing that. They're compiling together these open source technologies. But what they're also doing is they're making an API call to Anthropic, or they're making an API call to Amazon Web Services, or to GCP, or to Twilio, right? Or to some storage service somewhere. And when you're doing that, you're basically creating this dependency, this web of dependency, a lot of centralized providers to basically control and manipulate your data, and where you have less and less control over the quality of the product that you're delivering to your customer, right? And so the amazing thing about Bittensor is it basically provides a language for developers to build technology in a permissionless and incentivized way, where they're economically incentivized and rewarded to do that based on how useful and how disruptive the output of the subnet is. And that's why we call them digital commodities. When we call them digital commodities for a reason, it's really taking a page from the history books of how all technology has really been developed, which is it originally gets created for really wealthy, powerful people. And then over time, it gradually gets commoditized and more and more and more widely available for all of the less powerful and all the less rich people, until eventually the whole planet has free, abundant access to what was created. For example, I don't know, the microwave or the refrigerator or the TV set or anything.
Technology in general is deflationary. Like the value you get per dollar goes up. And so you don't need as many dollars for value. Like we see this was the case for 20 years with the iPhone, until now you finally don't really need to upgrade your iPhone. Like it's good enough now, every new version pretty much. And what's happening with AI is you could tell technologies in the early stages, because AI itself right now is getting more and more expensive. And, to use kind of the next version of AI, you would have, if I needed to use Grok 4 for some kind of enterprise application or to build something, I'd have to pay more money now. The next version is going to cost me more money. And eventually, though, when it gets decentralized, the price per unit of AI, whatever that AI commodity is that's being delivered, is going to go way, way down. And this is where the function of Bittensor is. Like Bittensor is already the next generation of AI without people really realizing it yet.
Yeah, Bittensor itself is fundamentally changing the economics of AI in terms of how you really think about scaling things, right? I mean, Bittensor is really changing the ground rules or the playbook for how AI is incentivized itself, and also in terms of how it's governed and accessed. And additionally, in terms of how it improves and how it gets better. It's just multidimensional. There's many aspects of what Bittensor changes.
Yeah, like to use my example, let's say I was creating an AI business on my own without the help of Bittensor. I would have to hire a bunch of software developers. I'd have to store all these videos on AWS. I'd have to get a bunch of NVIDIA GPUs. And then my developers would have to write software to do frame-by-frame analysis of these videos. So, run them through various neural networks so I could categorize, oh, here's all the bullet wound guys. Here's all the heart attack guys. Here's, so we would have to figure out all the context. And so maybe I would need like a dozen really high quality, even 5 high quality programmers, which is going to cost me, a couple million a year. And then I have to develop a front end and an interface, so that people can access this AI model. And my point is really with Bittensor is that, okay, I can store the data on Bittensor for cheaper than AWS. There are at least 3-4 subnets that can do video frame-by-frame analysis, and then the validators of those subnets would make sure, oh, this was good this was good categorization, and they could take 60% of my data set and learn from it, and then the other 40% they can test to see if the outputs are good. So that's the miners and the validators, and let's say the gradient subnet or even the Targon subnet, I think does could do frame by frame analysis if I give it a video data set. And then Shoots that you mentioned can make the interface like, oh, here's now my user interface. So the Shoots is great at taking an AI model and making a user interface for it. And so, and I could do all this for probably 1/100th of the price. It would take me, even if I was using like OpenAI or Grok or whatever, it would be like 1% of the price ultimately.
Yeah, Bittensor really subsidizes and commoditizes at a level of intensity and effectiveness that perhaps parallels or even surpasses what open source does in the context of software. Like, it's deeply profound. And when I say open source in the context of software, that is probably the highest bar, or like the most impressive sort of threshold in terms of a phenomena that we know that accelerates the rate of commoditization and disrupts things, right? So like when you open source something, it's super fucking disruptive. It's like, wow, like it doesn't feel good to be the recipient of the open sourcing of a thing that you made and is a really profitable monopoly, right? Like, you don't want people to have the open source thing succeed, but this continues to happen time and time again for decades. Open source is super disruptive to commoditization of technologies. I believe, and this is a really huge statement, and I think it's the first time I'm sort of conceptualizing this, so I should tweet it later, but I think Bittensor is more disruptive in terms of the commoditization of technology than open source. It's crazy. It's crazy to say that.
And it's funny that you say this, because it makes me think, here's what the reason is. Let's use the Google example. The Google example is a great example. So all the way back, I would say even Tim Berners-Lee, who made the first web server, I believe he also created an open source web spider to search the 100 or so websites that were out there in 1992 or 93. So he created this open source web spider. So Spider is essentially the engine of a search engine. It goes to every site one by one, and it downloads the site to your server, and it categorizes everything on the site. So then people would use this open source web spider to build their own algorithms, like those first search engines like Lycos or Excite or AltaVista. They would say, oh no, I'm going to use this web spider, and here's how I'm going to categorize information. It's a little tweak that I think is better. And Google, ultimately, Larry Page had PageRank. He had the best algorithm of it all. But the reason why, let's say I was using this, I'm coming up with a search engine in the 1990s, I have to sort of research these open source web spiders by myself and figure out which one's the best, and then come up with my own tweak on it to create a great search engine. But think about it, if you were doing this on Bittensor, there would be a subnet where the miners, every miner on the subnet would contribute a faster and faster web spider, and the validators would say, sure, this is the fastest. And then maybe there's even another subnet that takes the fastest web spiders, and they're all competing to categorize information that people like better and better. And the validators figure out some way to confirm that. And then there's incentives. Like, I want a search engine that's the best. I'm paying in Tao into these various subnets. And that's how the incentive mechanisms work for the miners to deliver these open source web spiders, but tweak them enough that it's optimal. You can make a Google for almost nothing using open source plus Bittensor, because I think Bittensor makes community. The incentives not only bring in open source, it brings in community.
Massive community. I'll tell you something really interesting that I've learned through the Bittensor project. The first CMO of Google is this guy named David Lowy. He's also the founder of Capital G, which is the growth fund for Google. $10 billion now. It's all Google balance sheet capital, but they've built a very successful portfolio. David was the founder of that. David is now the co-founder of Crucible, which is a Bittensor lab company, co-founded by Alice Shabana, which is the co-founder of Bittensor. And David actually built, we should have him on the podcast at some point. I'm friends with David, so we can definitely have him on. He built a decentralized Google before joining Google. And
Oh, so
it really impressed Larry and Sergey, actually. And that's why they hired him, in addition to him being a talented guy and stuff. He actually attempted to build a decentralized version of Google. So your example is so spot on, James, because you could theoretically, I mean, perhaps this is something that Bittensor should build. Scraping, indexing already sort of happen. In fact, Subnet 13 Dataverse incentivizes scraping. I think we were discussing last time. So you could definitely build a spider sort of framework incentive mechanism and register a subnet that actually rewards developers, miners, to mine the potentiality of that type of computation or that type of proof of work of discovering the web more efficiently through a graph. Actually, there's a graph optimization subnet as well. I can't remember the number that rewards
what do you mean
people.
graph optimization?
So the miners get rewarded based on the success rates of solving different graph optimization problems in different contexts. So, and they have different benchmarks in different applications. But if you can come up with a really effective graph-based search algorithm that you can apply to a lot of different domains, and depending on how you apply it, it could be very profitable. You could apply it in the context of cryptocurrency trading. You could apply it for, basically doing fraud detection, fraud discovery, labeling of data, all kinds of different. So the granularity of subnet incentive mechanisms or of the types of computations that you want to reward people to do, the granularity can be super precise, or it can be really broad, right? Which is like, collect a bunch of data from these really difficult to access data sources. And I want to just reward you for continuing to collect all that data. And the subnet provides an access mechanism for the data, right? That's a little bit broader. Or you could say compute aggregation. I want to provide an incentive for miners to aggregate a huge amount of compute. That's what Celium is doing with 51. That's what Targon's doing to a good extent with 4. That's what Basilica is, a new subnet that's doing that. There's this category of compute subnets. That's actually a pretty successful category. And then within Bittensor, we have competition. So it's competition all the way down. It's competition at the level of the subnet category, which is like compute subnets. It's competition at the level of the incentive mechanism on the subnet for basically rewarding miners differently. So you can say, I want to reward miners that provide compute at a certain availability sort of response rate. And so some subnet owners doing compute might really optimize on availability and speed, whereas other compute subnets might say, I just want to aggregate as much compute. I don't care as much about the speed or the sort of access of the compute, but I want it to be available for people that want to do batch operations on gigantic data centers. But my SLA and my reliability threshold is going to be like 4 or 5 days of uptime for you. And then I've got to move the compute to something else. There's so many different ways that you can carve this. This is why we have a very diverse cloud computing industry. We don't just have Amazon, AWS. We have AWS, we have Azure, we have GCP, we have neo clouds like Nebius and CoreWeave. We have, this huge ecosystem because there's so much diversity in the way that you can shape incentives. One thing I want to mention, and I think you were kind of scratching at this earlier, when you say run things on Bittensor or Bittensor serves the data or Bittensor is doing all this work, it's not truly accurate in the same way that Bitcoin does not actually run the computations for the cryptography of the SHA-256 hash rate. Bittensor's network verifies. Bittensor's network records the incentives and it records the transactions, but it does not actually run those computations. So Bittensor was designed directly after Bitcoin in this way. And it's very unique in crypto. As far as I know, there's no other blockchain that's done this and reached the level of success that Bittensor has, except Bitcoin. So literally across the hundreds of blockchains that we have, thousands of blockchains, there's only one that's taken this design principle from Bitcoin and reached the level of success it has without venture funding and without, I mean, even with venture funding, I don't think any blockchain has this. And the design principle is the following. Okay. You record the incentives on chain for computations that happen off chain. This is very important. So Bittensor is literally just an incentive language. It's just an incentive language. There is no big Bittensor computer running on the internet like BitTorrent or like, IPFS or something like this, right? Or Ethereum, where you've got on-chain storage and all this kind of stuff. That does not work. In the world of computing at a very large scale, at an internet scale, that does not work. The on-chain computation thing does not work at an internet scale. What Bitcoin does, it says, here's a reward mechanism. Now go and solve SHA-256 at a certain difficulty threshold. And that threshold is going to keep going higher and higher if the network attracts more compute and more miners. And it does. So if you look at the hash rate graph of the Bitcoin network over the last 10, 15 years, it's basically a hockey stick graph. It's been going up and to the right. And that hash rate, if you were to measure it using conventional comparisons to how much computation is Amazon doing or is Google doing, right? Like, what are the big measurement bars? Elon's biggest data center, right? The electricity requirement and the computational output of the entire Bitcoin hash rate is orders of magnitude. It's like thousands of times more compute than all of the data centers combined in the world. And that compute is dedicated to one cryptographic hash function, which is SHA-256.
Which in turn validates transactions.
SHA-256 provides a large enough entropy space of complexity to guarantee digital scarcity and verify it at a level of a very large decentralized network. But the actual computation to compute the correct hash, it's very, very computationally expensive. It requires a lot of electricity. And so that's why people build ASICs and custom computers, and then they run them in China or in the United States or a few other places in the world. But when you run that hash rate, you're not running it on the Bitcoin network. You're not running it on Bitcoin. All Bitcoin is doing is says, run this hash rate at this level. When you acquire the correct nonce, you broadcast that to the Bitcoin network. Bitcoin can verify that very efficiently. We're not talking about spending electricity to do the verification. The verification happens on chain and the incentives happen on chain for Bitcoin. The ASICs from Antminer, Bitmain in China that make the computers that compute SHA-256, those ASICs are running on Bitcoin. They're running in mines in China and in mines in Tehran and in Iran, right, where electricity is inexpensive. And they're running in Kazakhstan, and they're running in a few other places in the world that are very electricity power efficient on a cost basis. And they're not running on the Bitcoin network. Okay, they're producing a cryptographic hash that meets the acceptable complexity threshold that Bitcoin is looking for. And when that piece of data, which is a small amount of data, we're not talking about like this gigantic data center that you need. You take that little piece of data and you broadcast it to the Bitcoin network. And then if you're correct, guess what? You get rewarded in a Bitcoin block. Wow, that's incredible. You made 3 Bitcoin. You know what's also incredible? 3 Bitcoin's worth almost $500,000. So, wow, holy shit. That's the Bitcoin block reward, right? It's 3.125 Bitcoin per day at the current halving schedule of Bitcoin. Bittensor works exactly the same way. No other blockchains work this way. In the top 100.
So give an example of a blockchain, like let's say Ethereum. How do they do the compute on chain?
I'm not an Ethereum expert, but the compute happens on chain because the Ethereum network focuses on a specific type of computation, which is instead of SHA-256 on Bitcoin, Ethereum's aim, which is, I believe, Vitalik's vision, was to provide general purpose Turing complete computation of any type of mathematical operation that you would like to do or implement in what's called a smart contract. And the smart contract is very transaction obsessed. It's very optimized for transactions, specifically financial transactions, right? And so when you write a Solidity contract that manipulates the objects of Ethereum tokens in that contract, it's inherently financially oriented to the logic of that type of operation, right? So it's a financial, arbitrarily expressive sort of programming language for financial transactions. It's not meant or wasn't designed for cloud computing and storage and all these other things. That's why we have Filecoin and we have a lot of these other types of services. But the Ethereum network itself chooses and desires to put everything on chain. You want to run all those operations on chain, and you want to cryptographically verify and ensure all those transactions actually happened on chain. Bittensor is very different. Bittensor incentivizes very complex and very difficult to scale types of computational tasks and efforts and units of work, which in many cases have nothing to do with finance. And those units of work and those computations happen off-chain, and the Bittensor language and the Bittensor network does the record keeping and the verification of the output of those tasks. That is in the same exact way that Bitcoin does this for SHA-256 and for proving that the network is more and more secure, and connecting the incentive language of Bitcoin to this very narrow, this very specific type of cryptographic hash computation, SHA-256, in a level that produces a huge amount of security and protection for Bitcoin's network when that proof of energy and that proof of work is verified. Bittensor does that. Ethereum is not in the same category. Ethereum is a totally different kind of technology. What Ethereum wants to do is it basically wants to be Python to Bitcoin's bash script, right? Bitcoin is a bash script, or almost like a regex, like the Bitcoin script, the Bitcoin like language for like writing contracts on Bitcoin is so primitive and is so minimalistic that basically Ethereum says, we'll do something similar. We'll have to protect and prove that the network is secure and reliable using different methods, which is what they do. But their objective was to say, we want to make it so that financial developers or engineers can write these Python level expressive programs, which is Solidity, and you run them on our blockchain that verifies all the different financial complexities that you want to do. Bittensor supports the EVM. The network added support for the EVM in December of last year. So what some people are doing on the network is they're writing Solidity contracts from Ethereum and actually plugging them in to further extend and add flexibility to alpha tokens on subnets, as well as what you can do with Tao. So this is very interesting, and this is actually providing more tooling and more flexibility for Bittensor developers. Ethereum and Bittensor are in two different categories. They're two different technologies.
Yeah, I always tell people in a very, very simplified way, Bitcoin's like a currency, Ethereum's like a programming language.
Correct.
They're just different things. And it's very interesting what you're saying, that on Bitcoin and Bittensor, the computation, the work happens off-chain. That's why there's other crypto tokens like Chainlink, which brings information from the outside world onto the Ethereum blockchain so that Ethereum can now make calculations with it. You need a whole token to do that, as opposed to just doing what Bittensor or Bitcoin do. And just to simplify further, what you were saying about Bitcoin does all this computation, that's in order to basically, for these miners, the ones doing the computation, to prove that they're good enough to validate transactions, so that this way the Bitcoin network keeps working. Because there's no bank in the middle validating transactions, so you need somebody to do it. So you have to have this competition to say, hey, I'm good enough to validate a transaction. And Bittensor is similar in that everyone is, the miners here are trying to say, I'm good enough to contribute this AI model or this NVIDIA GPU or this data set. Like, I have something good, so I am deserving also of incentives. And the validators or the customers say, yes, this is good.
That's correct. And the incredible thing about Bittensor, again, to sort of like bring this point home about off-chain computation, is that it's infinitely scalable. You can scale to arbitrarily large. That's a technical phrase of, at any level of size. I've mentioned this on Twitter a few times. People are like, what do you mean by arbitrary? I'm like, it's like a technical phrase. So this is why if you design an incentive correctly through a subnet, you can produce arbitrarily large outcomes if the actual production of the work happens off-chain and using whatever methods are available to the miners. Now, the miners definitely need a validation mechanism that is airtight and provably measurable, and that's very tricky to do. A lot of the subnets are still experimenting and exploring how to very precisely and accurately provide a measurement mechanism for their commodity, for their output. Why is this important? Well, again, if we go back to Bitcoin, Bitcoin works because verifying whether or not you solved a specific threshold of SHA-256 hashing is mathematically provable, right? Like we can verify that it happened. All you need to do is show us the nonce and the hash, right? And so mathematically provable, cryptographically provable. Whereas a lot of the units of work and the units of digital commodity production on Bittensor are more subjective. In fact, they are concretely subjective. And so this is why UMA consensus exists. If you want to get really technical, we can talk about UMA consensus, but UMA consensus is the first in history. And this is, again, another thing that like is very under discussed and underappreciated by Bittensor, about Bittensor in the broader community is Nakamoto consensus, which is the consensus mechanism on Bitcoin, basically uses the verification that you get for free of a cryptographic hash to provide deterministic, which means, mathematically provable verification of the work. On Bittensor, because the work, the proof of the commodities is oftentimes probabilistic and subjective, well, you need the consensus mechanism for the network to be probabilistic, and it needs to be, fuzzy and subjective as well.
So just an example, like some subnets are prediction subnets. So people make predictions on stock market prices. The validator, when they're validating at first, they sort of have to make a guess that this prediction might be correct.
Yes.
And so then there's different, every prediction subnet on Bittensor has a different way of doing that. But I think that's what you mean by probabilistic in this case.
Well, it can actually go even far more broad than that. When you talk about the quality of an AI model like an LLM, you're comparing Grok, you're comparing ChatGPT, Perplexity, Claude from Anthropic, you're comparing the Gemini models from Google, right? You might use some of them and say, well, that output is kind of more accurate, but, I think this other model's better. And then if you ask the same thing to someone else about, the quality of an essay or the quality of an image that it generated or the quality of a piece of code, you might get a different opinion. So it's subjective. The outputs of LLMs are sort of almost inherently or fundamentally subjective in terms of their quality, which is why the benchmarks are all crazy. All the benchmarks are like, we're saturating 95th percentile on this particular benchmark. Well, who cares about benchmarks? Benchmarks don't matter, right? Like, humans aren't meant to be put in a cage about saturating some human invented benchmark. We're supposed to be creating new knowledge and new information and inventing new physics and inventing new science and inventing new knowledge and discovering new things that we didn't have knowledge of before. We're not supposed to be just like, benchmarking each other on these finite, rigid boxes of intelligence. This is stupid. I don't know why we're doing this. However, this is how you actually measure, the value and the usefulness of a model. That's subjective. So Bittensor solves for this by incorporating a probabilistic or fuzzy or subjective consensus mechanism for the network to say, for some of the commodities that are going to have outputs that are a little less or, not deterministic at all, we need to basically allow the free market of expression to rank and order the way emissions work. And it's very, very similar to the way markets work. Market-driven, free market capitalism-based expression of ranking is the closest approximation to natural selection and the evolutionary biology of our species, right? The strongest survive, the most fast to adapt survive, et cetera, et cetera. It has nothing to do with saturating a benchmark.
Is there room for corruption? Like, can DeepSeek pay off the validators on gradients? Hey, use us to be the learning models for all gradient stuff.
There's a lot of corruption on Bittensor. There is absolutely room for corruption, and it happens all the time. And in fact, I know of a few places where it happens, and I know a lot of the teams that participate in some of this inside dealing and corruption. I would also like to point out a few things. If you look at the current capitalist world that we happen to be inhabiting, do we see corruption between the makers of the device that several billion people use every day called Apple, paying the Google search monopoly tens of billions of dollars a year? It's the other way around. Apple pays Google tens of billions of dollars a year for the privilege to be the default search engine on the Safari browser on the iPhone, right?
You mean Google pays Apple?
Google pays Apple. Google pays Apple.
Yeah.
This is cartel-like monopolization of technology at a level that most people don't have the ability to comprehend. I mean, we're talking about tens of billions of dollars in sort of inside dealing. There's deeply entrenched supply chain favoritism between Jensen Huang, the CEO of NVIDIA, and Terry Guo and the Foxconn organization in China. Foxconn manufactures most of the iPhones, but they also assemble and are the largest supplier to NVIDIA, right, of the NVIDIA products. Another supply chain favoritism entrenchment thing is TSMC, run by Morris Chang, the legendary Morris Chang, a legendary entrepreneur. But guess what? Because of the monopolization and centralization of those capabilities in one company, we have, very significant supply chain risks. And we often talk about them, but they are so deeply pervasive across all of the geopolitical system that China is not going to go and take over, Taiwan in an afternoon because they feel like it, right? Like, if that happened, they would be directly affected because they don't have their own escape hatch for how the chips are actually made. The chips are made in Taiwan by TSMC. Literally all of the world's chips are made in Taiwan. All of them. It's not like some of them. It's like 95% or something gigantic, right? One company. And there's been worker strikes. There's been invasion risk and scares from China, and they've been saying their explicit stated, mandate is that Taiwan is a part of China, right? It's like, no, they don't recognize it as a separate country, right? So, you're part of mainland China, actually. And so this is why Bittensor is such a profoundly important stepstone transformation for capitalism and for money and markets and innovation in general, which is, if you break apart all of the reasons why businesses succeed, they fundamentally succeed because someone noticed a problem that needs to be solved in the world, and it was personal enough to them that it was a mission, and they went out and they did it. But then over a long enough period of time, you have government currencies and monopolistic markets that concentrate a lot of that power into a very small handful of businesses. And right now, equal access to those businesses' products might somewhat be a reality, but equal contribution and equal ability to impact those products is far from a reality. The opposite is true. Like, almost no one has the ability to go and influence and have a significant share in how you would evolve, the iPhone as a product, or NVIDIA chips as a product, or the AI models that you use every day as products, or, the internet services that you depend on every day. it doesn't really exist. The closest thing that sort of solves for that is this incredible ecosystem called open source that was kicked off by Richard Stallman in the late 1970s, early 1980s. And wow, that has paid dividends for technical people, for developers, for programmers. And I know you're a programmer, James, you have a technical background. For normal people, the exclusive dynamic in the technology industry is so pervasive. We have Robinhood going and saying we need to tokenize Stripe shares and OpenAI shares. And everyone's like, hell yeah, I want to get in on that, because those are fast growing businesses. Those are really awesome companies that are transforming the world and they're doing all this great stuff. Why can't I participate as a retail, individual consumer, just in the upside, the financial upside of those products? I'm a fan. I want to speculate. I want to buy the stock, but I can't because it's a private company and only rich VCs, like JJ and James, can get involved in those companies. Like that's not equal financial empowerment for the world. It doesn't include the world in the upside of these technologies. So I think Bittensor is very disruptive to that. And I think that the Overton window on these conversations is changing, because we have, for example, Brad Gerstner from Altimeter doing something which I think is incredibly remarkable, and he should be lauded for the rest of his career. And he's had an incredible career, made tens of billions of dollars investing in companies like Snowflake and also NVIDIA and Meta and many others for his investors. Very successful investor. And he just got, with Michael Dell's help, the Invest America Act merged into the Big Beautiful Bill, which has all kinds of issues, but they got this plugged into that bill, and it opens up an account for every newborn in America that gives them exposure to the growth of America. It's an index. They get exposure to an index, and the government participates in it, and there's ways of getting it more heavily funded. But basically, every newborn in America will have an account open where they lock it up until they're an adult. And by the time they're an adult, they will have seen and benefited from being exposed to the top index of the technology and the innovation coming out of America. But again, that's only in the public markets, right? They're not getting exposure to early stage OSS Capital or Sequoia or Altimeter funds, right? They're getting stock exposure, right? What Bittensor does is it takes this vision, this idea, to a whole new level, right? What Bittensor does is it says, at the inception stage of the creation of the technologies, you have the ability to participate in the financial upside of whether this thing actually goes and changes the world.
And it's not only participating as an investor. This is the beautiful thing. By buying Tao tokens, you're actually creating the incentive. You're actually part of the system now. Yes. You're not just saying, oh, I want to buy shares of all the AI innovation. No, you're actually, the AI innovation can't happen without people buying Tao tokens. That's the beauty of this. We're a part of the system, not just an outsider investing into it.
100% correct. And I would use the analogy of how Bitcoin is solving the problem of monetary manipulation and hyperinflation, which is really happening in most of the top countries because of the debt issues and the horrible productivity numbers. But I would say Bitcoin is a grand repricing of all fiat assets. Grand repricing. Super brilliant kid put a tweet out the other day saying, if you look at NVIDIA in BTC denominated terms, Bitcoin denominated terms, NVIDIA is worth less every year of the last decade. Every year by like 10 or 20%, right? Apple's worth less, Google's worth less, denominated in BTC, everything's worth less. Denominated in dollars, they're worth more because the dollar continues to get inflated away. But BTC is deflationary inherently. And when you go and apply that type of monetary structure, which rewards you for participating in that system over time, it rewards you. That fundamentally changes the economics. My view, and I'm a Bitcoiner for sure, I'm a Bitcoin, mega fan, is there's this grand repricing we're going through and witnessing right now in the timeline of humanity. And 15 years is a blip. Bitcoin was invented and released 15 years ago. This is a blip, right? Like humans were writing things down only 5,000 years ago, and we invented computers like 100 years ago. Like 15 years is a blip. We've created 2.5 trillion of repricing of economic assets from the world of fiat and stores of value like gold, perhaps, onto this permissionless, decentralized, incentivized layer called Bitcoin.
And why do you think Bitcoin achieved this escape velocity, that people did accept that, yes, we're willing to say that this new thing is going to do this repricing?
It's a combination of things. It's hard to boil down to one. But if I had to surmise, and I'm not a deep expert here, I'm a student of Michael Saylor and Anthony Papliano and like all of these people. I listen and read avidly. What I think is happening is across the sort of stratosphere of like normal people, going about their daily lives and sort of like, median per capita income, all the way up to mega billionaires and people that run the world, that run the whole world. I think the observation is the following. Governments are inflating their currencies away into oblivion. And Ray Dalio is likely right that when the currencies get devalued to a certain extent, you start to see civil war conflict and wars and changing of guards in terms of who runs things, right? Like stuff gets reshuffled around a lot. This is not new. We have seen this in history, and this is something we can learn from the history books, right? It happens time and time again. For a variety of reasons, governments get very sloppy in terms of how they manage their fiscal policies, and they inflate away into oblivion because that's the only tool that they know how to use when push comes to shove and they're pushed against the wall. They inflate more and more and more. And so that's the observation from everyone.
I'm sorry to interrupt. The basic examples: Weimar Republic, Germany in the 1920s.
Yes.
They had all these war reparations they had to pay from World War I.
Yes.
They didn't really know how to pay them, so they printed more, marks, Deutschmarks, and it eventually cost 1 trillion marks to buy a loaf of bread. And the worry is this happens in a great percentage of countries already right now. The worry is that eventually it'll happen to the world's reserve currency, which at the moment is the dollar.
That's correct. And I believe it will happen to all of the most powerful currencies in the world and all of the largest countries in the world that have human controlled and basically manually fine-tuned currency policies, right? So like the central bank equivalent in China is, the totalitarian dictatorship of Xi Jinping and the CCP, but it's still run by humans. The currency controls in the United States are the Federal Reserve, Jerome Powell. It's kind of like a separate part of the government, but it's still deeply integrated into how, the overall democratic process works. And, that's run by people. You've got the network of Federal Reserve banks around the country. They all kind of meet up every quarter or so. FOMC, it's like 15 people or something. I know a couple of them actually have like reached out and like tried to contact them. And I had one conversation with Neil Kashkari. He's one of the Federal Reserve people. And these are just like normal people. They're not like, Einstein geniuses. They're just like normal people. They look at the employment data. They look at the jobs data. They look at the price of goods and services, and they look at the growth of productivity and GDP. And depending on their interpretation of the data, right? They adjust policy and set rates and the cost of money. That is absolutely insane. That is insane.
It is insane. I'll give you my own example. So in March 2020, I had on my podcast one of the deputy governors of the Fed, and my worry was, can you shut down the economy and print trillions of dollars of money at the same time? My feeling was no. But not only did this guy, but a world famous economist also I had a discussion with. I won't embarrass him by saying his name, but they both said, yes, we could. Right now there's so much demand for the U.S. dollar. We could print $1 trillion a month forever, and there would be so much demand for it. And the deputy governor said to me, of the Federal Reserve, said that their main worry was deflation, because no matter how much they're trying to have inflation right now, the economy is deflating, so they feel this is a good excuse to just print as much money as possible. And of course, they turned out to be wrong. In 2023, we had, double-digit inflation for the first time in, 30 years or so, 40 years. So they were completely wrong. And to your point, one of the purposes of Bitcoin was to avoid human error. And human error not only being how much money did I deposit in my bank account? Oh, it's a different number. You got it wrong. It's how much is the Federal Reserve changing the value of the dollars in my pocket? That could be a human error. And Bitcoin, through code, basically, doesn't allow human error.
Yeah, absolutely. Now, Bittensor, while it's designed using the same principles of Bitcoin, this inherently deflationary, scarce, halving schedules, cryptocurrency for creating incentives that enable people to do useful work and useful computations. It is ranked by humans. The validators on Bittensor are humans, often making subjective decisions. But again, that's a function of how well-defined your commodity is. If it's extremely well-defined, you can provide a more accurate incentive mechanism for it. So in the same way that the better you can measure something, the better you can describe it. If you're not able to describe it in excruciating levels of detail, you won't be able to verify it properly. This is why we have math. Math is the ultimate, most secure language of expression for things, math and physics, which, physics depends on math and vice versa, I think. And so, if you fail to have a subnet where the commodity production is so precisely measurable and descriptive, your subnet will likely fail because people will not be confident that the speculation from alpha holders and the miners and the validators is deserving of Tao, is deserving of staked Tao, right? And Tao is the global kind of like incentive currency. And I agree with what you were saying in the last conversation. I don't think of Tao as a currency either. I think of it as the actual incentive for the sort of the ecosystem of subnets that need the scarce asset to basically provide the pricing mechanism.
It's really important because let's take the word capital out of capitalism for a second. Because, capitalism as a word was more or less created by socialists. So Karl Marx was a heavy user of the word capitalism. There was a socialist before him. I forget the name in the 1800s that defined the word capitalism. They basically meant it to say that some people are out there accumulating capital, and that's unfair. So it's not a real word. But I think Bittensor, if you take one word to describe Bittensor, it's incentivism. And it's as you were saying, the language of incentives. That's really what drives productivity, drives the world. Why do I get up and open a shoe store? Is because I have an incentive. I might have some skills in making shoes. I need to get food to pay my family. So the activity I do making shoes gives me an incentive, or is an incentive enough to give me whatever I need to buy food. The fact that it's currency there doesn't even matter. The currency doesn't drive anything. It's just like a bridge. But the incentives are everything.
I think of the analogy that Elon used when he's like, if you had $1 trillion and you're on an island and you need to have some fresh water and, have a meal, your $1 trillion is not going to be worth anything.
Right. Or like Yuval Harari puts it, like currency is just a story we tell ourselves to give it some value. But what really is value is food that I can eat and the things that I have to do to get that food. So I think that Bittensor is a pure form of that, where Tao kind of is this abstract way of saying, here's the incentive in the middle. And you're right. So let's say there's a subnet that has some corruption in it, or let's say there's a subnet that's not defining its metrics well enough for miners and validators. Then there's not going to be enough incentives for those miners to work, and there's not going to be enough incentives for those validators to do a good job. They're going to drift to other subnets, and then that subnet that is losing the miners and validators, they're not going to have anything to offer customers, so all their incentives are going to go away. The emissions go away, the alpha tokens go away, the Tau goes away, and they're going to disappear. And I sort of feel Bittensor needs some failures to prove that this isn't this like holy land of money and speculation where everybody is just a genius once they have a subnet. Like there needs to be failures, and just like there needs to be successes to show the success of Bittensor as a network.
100%. I think, if we go back to inflation of central banks, there are ways where you can inflate your currency and take advantage of its dominance to further entrench your leadership. So this is what China did. They printed somewhere between 35 and 40 trillion dollars of the renminbi over the last 15 years. And the United States printed about $20 trillion over the last 15 years. So people go, wow, that's a 2x difference, roughly, right? China's printed way more. Here are the big differences in terms of how it happened. China printed it more evenly across the 15 years, more evenly spread out, call it roughly almost exactly evenly, a little bit bumpy during COVID, right? Because we had stimulus, we had government response, but it was pretty evenly spread out. United States, we printed 90% of that 20 trillion in 2020.
Yeah.
90% of it, and it all went to stimulus. That's where it went. It went to stimulus mostly. This free checks. China, where did they apply that money? Because it didn't get concentrated in one year like 2020. It was spread out across the 15 years, remember? Right? So where did it go? Their stimulus that they printed went into industrialization, manufacturing, robotics, energy, AI, all of these things. And that's why we have been left in the dust in the West, because China has made a realization that they can inflate their way to dominance on the global scale, which is what they've been doing.
And it's true. People don't realize that it's not just the printing of money. The printing of money has to be balanced by increases in productivity. If your economy, gets more productive percentage-wise or similar to the amount you're printing, then your economy can absorb it because there's more products, there's more customers, there's more need for incentives. So it's okay to have more money in circulation. The problem with the US, particularly in COVID, is that we were printing money at the exact point where we had negative productivity. So that's why then immediately afterwards, there was the biggest inflation in 40 years. So,
Yes.
and people sort of realize that now, even though it was obvious then, but for some reason, economists were doing everything they could to justify the printing and not using their normal models.
Yes. Yes.
Milton Friedman said, money supply is the heart of inflation. And the money supply increased the most in history during COVID. And then there was inflation. Sort of it was like a one-to-one relation between what Friedman said and what happened.
But it was an extreme human-led reaction to an unpredictable black swan event. And if you have these types of events that occur, the next event might not be a large pandemic. It might be a geopolitical conflict. It might be escalation of something geopolitically. It might be a technology hack or technology disruption of some kind, right? Like that cannot happen again in terms of the extreme reaction of a handful of people. And so this is why we need permissionless, incentivized, decentralized protocols like Bitcoin and Bittensor to solve these problems. So there's this grand repricing with Bitcoin. In Bittensor, there's this grand repricing, not of fiat currencies, but of AI superpowers, basically, right? And so look at Google, look at OpenAI, look at all these big companies. Bittensor reprices and reorganizes the incentives for those types of platforms to be much more democratic and much more accessible for everyone, and also permissionless and mechanistically, something that we don't talk about enough, but is actually fundamentally required of Bittensor, is all of the commodities that are released on Bittensor have to be transparently verifiable, which means they actually have to be open source and they have to be open, right? And so that's like super profound.
It's so interesting because let's look at a very basic example. Let's say I just want to program my own, LLM. I'm going to need, potentially thousands of GPUs to process a huge data set so I can make my own large language model. And so in terms of repricing, if I'm Elon Musk, as you mentioned last week, I'll go to Memphis, Tennessee. I'll buy 200,000 NVIDIA GPUs. I'll spend $40 billion and I'll be able to write my own large language model. But here's where the repricing happens. I'm just a programmer sitting at my home. The NVIDIA GPUs are, people are donating. Like, for instance, data centers that don't do AI are donating the spare, like they're just storage centers. They're donating the spare cycles on their GPUs to Bittensor so I could program on top of them using those GPUs. So this
They're
is just a
actually
simple
not
example.
donating. They're getting alpha rewards. They're
right,
getting economic incentive.
So
They're
so
getting
right.
paid.
So donating is the wrong word. That's right. They have an incentive to do it. Like I was
That's right.
talking to a data center company, and I mentioned them last week. I was talking to a data center company. They're making specific servers that they deliver to their customers that it's built in that they could then mine, put these or make these GPUs accessible to Bittensor so that their customers and themselves can share in the mining benefits on Bittensor. They can get Tao rewards. And then me as a programmer, maybe I'm doing the programming as a miner for a Subnet. Now I'm going to have incentives too. I'm going to get rewarded in Tao, particularly if there are customers. And the customers are incentivized because for their own reasons, they need to use my outputs, and I'm using the GPUs. So everybody is incentivized all the way around.
That's correct. Yeah, Bittensor is an incentive alignment. Yes.
It reprices then the development of AI.
It reprices AI to its most optimal pricing level, which is that what are the fundamental. Bittensor is almost like first principles for markets and capitalism, right? Like current markets are like almost like last principles, like or no principles. Like there's no rationale in terms of how you price something or how you incentivize something oftentimes, and it's just completely disconnected from reality. Whereas Bittensor provides this kind of economic discovery mechanism. It's sort of like a search algorithm that optimally discovers the space of optimal efficiency for pricing the creation of a useful technology or a useful commodity. And that is very, very hard to do in conventional markets, right? When you look at like startups, for example, well, you're going to have like a VC give you $5 or $10 million valuation, maybe $100 million valuation. And then you're going to give that team, that founder 2 years of time to develop a product. And then another year goes by that maybe they built the product and then you give them like a 200 million or 500 million valuation because they have some interesting metrics, or maybe they have like $1 million in revenue or 20 million in revenue. It's all subjective. It's all super subjective. And that pricing is so far removed from, wait a minute, if you looked at what they actually made as a startup, what was the fundamental cost structure for building that widget or that tool? It certainly wasn't blowing through $5 million of venture capital. It was maybe 200K or 100K of energy.
This is such a great point because, again, it's repricing. The VC valuations are all sort of arbitrary. Like if you live in Silicon Valley, you might get the $100 million valuation. If you live in Oklahoma, you're going to get a $2 million valuation. Like, so there's this geographic error that happens with pricing. And just like it's important to own Bitcoin to save yourself just in case if your currency collapses, even in America or any country, then all the 40 years of work that you've done to build a retirement is basically gone. It's disappeared. So Bitcoin, just like Bitcoin protects you against that happening, owning Tao actually protects you against valuations collapsing in the so-called free markets, because they're not quite free. It's who knows who, it's where do you live? There's various arbitrary factors in valuing companies. Are you public? Are you not public? That changes your valuation. Are you public on the NASDAQ as opposed to the Canadian public markets? That changes your valuation. So there's all these arbitrary things that change the pricing of financial assets. And owning Tao is like a way to protect yourself against that arbitrariness in terms of AI companies, or maybe more companies. I mean, AI companies is the start.
That's absolutely correct. And I've actually thought about what that would look like if every internet user that has some subscriptions, like say you spend $50 a month or $100 a month across 5 or 10 internet services, you've got like YouTube, Netflix, Gmail, like a handful of things, right? Many people increasingly have things like ChatGPT or, Grok or whatever, right? So, and those are the fastest growing products currently on the internet. So let's just take 1 billion internet users and say that roughly 1 billion internet users are paying, 10, $20 a month at least. In fact, they're probably paying more like $100 a month each, right? Which is about $100 billion per month, which is about $1 trillion a year in revenue, right? And that's about the size of, I would say, internet services spent across like all the products, like Google's products, Zuck's products, Apple's got cloud products, all the Asian variations, Alibaba, all those products over there. You've got all the ones in Europe. So you just add everything up. I would say there's 1 billion people on the planet spending around $100 a month across all the different internet stuff that they use, including apps, including mobile apps and everything. And, about $1 trillion a year in spend, right? If Bittensor was able to get just $10 from every internet user per month of Tao, $10 per month of Tao as a subscription, almost like you think of it as kind of like a subscription fee. But what you're doing is you're basically buying Tao at whatever price. You do not look at the price, but you buy $10 of Tao every month and you DCA over your life, basically. That would provide about $120 billion of liquidity into Bittensor every year. And if we did that, Bittensor, the network incentive for producing all of these continuously improving digital commodities, permissionless and aligned with humanity, not aligned with Google or Microsoft or Apple, the Bittensor network value would grow to the trillions of dollars. It would be as big as Bitcoin. It would be as big as Bitcoin, because currently Bitcoin inbound liquidity every year, is about $100 billion a year, and it's worth $2.5 trillion, right, at the current level. And so when that happens, that will be very interesting, because Bittensor's incentive reward for the miners and for the validators and the builders of these continuously improving permissionless and incentivized AI commodities will surpass what Zuckerberg can wield with his balance sheet. It'll surpass what Google can wield with their balance sheet, right? And then we're talking about Bittensor being a full replacement for basically technology services on the internet. That's where I think we're headed. And we need people to understand, hopefully people that watch this podcast, James, that if you care about your privacy and your agency and your autonomy and your influence over how you use technology and AI and how you basically have participation in that global industry, you need to really be looking closely at Bittensor, and you need to be buying Tao and following the development of the subnets, because there's 128 today. Next year, there's going to be hundreds more. The year after that, there's probably thousands more. Each one of these subnets is almost kind of like a tech company or a tech collective or a tech network. The analogy is not one-to-one perfect. It's not a company. It's different from a company. It's a different structure, but it's kind of similar. And, if you look at the current economic environment, we have the S&P 500, right? This is the 500 biggest companies in America. And we have the NASDAQ, right? Which is I believe the top 100 biggest companies in America, or the top 50 biggest tech companies. I think that's a tech index, right? The top 20 companies, the top 10 companies are 80%, 70 or 80% of the value of all of the companies, right? And so on Bittensor, this is something that I think is important for people to know, because this is really just like a fundamental law of nature. There are going to be significant concentrations of value and wealth and influence on Bittensor to what we see in capital markets today with the S&P 500, the Mag 7. It'll look very similar.
It's to a point you made earlier. It's the 80-20 rule. So 20% of the subnets are going to provide 80% of the value.
Correct.
And which means 4%, if you 80-20 the 80-20, 4% will provide like about 64% of the value. 1% will provide about 50% of the value. And that's what's happening. It's the Pareto's law. Yep. And here's the thing. I don't know if people really care that much about privacy or even bias. Like let's say you told me Grok invades my privacy and has bias. I'd probably still use Grok right now just because I can't really, it's hard to find alternatives, or let's say Google's Gemini or whatever. And this is both problem and opportunity for Bittensor, which is that I think subnets need to still improve their kind of front end and their marketing.
Absolutely.
I was just using 19.ai the other day. It's Subnet 19. You can actually make pretty good images much faster than normally I would use Midjourney. Midjourney, I think, has the best images. It's like you said, it's subjective. But sometimes Midjourney takes like a minute or two to come up with an image, whereas 19.ai, it's like half a second. And the same thing with text inference. But their front end, every time I go there, it's like I have to figure out again how to enter in a prompt to use it. Like, it's just simple things. They need to know. I feel like Bittensor is where the internet was in 1991 in some sense, where it was just a bunch of programmers using the internet because there wasn't a web yet. So you kind of had to be a programmer to use the internet. And there's not really a sense that, oh, we need to make a nice front end. There's the whole science of user interface that we need to use. Not necessary for every subnet, just consumer facing ones. And stuff like that needs, but that means there's opportunity. It means there's some subnets that are grossly undervalued because they have no user interface. And there's also opportunity for entrepreneurs to make front ends for these 128 subnets and rising. So that's an amazing opportunity all around for Bittensor, because we know there's subnets that have value,
really significant value, and there's diamonds in the rough that don't market themselves well. They don't have a front door or user interface that is accessible or simple for just mainstream internet users. That they don't want to swim through any complexity. They want to click a button, put their name in, and they want value and functionality right away. And so, I think of Linux as well. I think of Linux in the early days of its ascent was hackers, hobbyists, basically hippie programmers. And
they were offended by regular people using Linux, like companies using Linux.
Yes. And that was not healthy. But what mattered is the people that were building the platforms that ended up really taking over the internet. They understood that they needed to use Linux, and everything took care of itself after that. Linux became the dominant thing. And, the big problem with open source, though, is it's been missing this inherent economic model, right? The incentives for open source are intrinsic. You do it because you love creating of transparent, free technology. You do it because you want to learn from the best people. You do it because you want to solve your own problem. Open source is exclusively intrinsic, which means that you don't do it because you want to make money. You do it because you know you're not going to make money, but it still feels great and you still do it, right? That's why people do open source.
Right, and why they love it. You're doing it for the love of it.
The love of it.
Just my own example. I remember like in the mid to late 80s, I was working on GNU chess. So, GNU is the Richard Stallman, open source group. And they made a chess program that was open source chess program. And then my exposure to chess software, and I ended up working on lots of different projects related to this, started with using this free open source software and trying to improve it. And I just felt great doing it.
Mm. Yeah, it's that intrinsic, that sort of altruistic kind of feeling. Whereas with Bittensor, it's intrinsic and extrinsic, because when you build something and you actually solve the incentive mechanism properly, you get paid liquid currency or liquid money that is denominated in whatever the world happens to be, anointing as the default currency, which is the dollar today. So if you earn the alpha token off of a subnet, you can convert that to Tao and then basically get paid in whatever currency that you want. And that's extremely powerful. That to me feels like almost an upgrade to the way open source works. It almost feels like the replacement or the successor to open source itself, but because it combines the economic model with the intrinsic model.
And the economic model is important, but I'm curious what your thoughts are. Like, let's take Templar as an example versus something like a Schutz or a Gradients. So Templar is, correct me if I'm wrong, basically it's a subnet that made their own large language model. It's not as good as ChatGPT or Grok, but it's this thing that where the motivation is more or less intrinsic. Like it's a bunch of miners and validators who felt like, hey, I want to contribute to this so I can make my own LLM. And they get rewarded and so on. But compare that to a business, like let's say Gradients, where they're actually offering subscriptions to make, for people who need to make or access the APIs of open source learning models like DeepSeek and so on. So there's a subscription involved. I won't get into the details of what Gradients does. They basically help you make your AI model. And they use the revenues to do buybacks of their token. So now it becomes extrinsic. I could mine on Templar because I love the free aspect of making an open source LLM, but I'm limited to their alpha token rewards. Or I could do it. I could be a miner on Gradients doing something very similar, but I'm going to get rewarded more because since they're doing buybacks based on their revenues, the value of my alpha tokens is going to go up.
Humans have extremely creative ways of justifying prices for things. So, for example, when a company is synthesizing a drug, but there's no certainty about when it will pass the trials and the hoops, and they have zero revenue. But people know that there's a really great CEO, medical board, all of these great engineers, they have labs, they have all the stuff, and they've raised a few billion in funding, and the stock's going to get valued at 50 billion or something crazy. No revenue, again, no revenue. That phenomenon, I think, is somewhat similar to how Templar is getting priced on Bittensor. It's a top 3 subnet in this microcosm of very high volatility on Bittensor, which is a crazy, chaotic, highly volatile economic marketplace, really, for digital commodities. 1 month, you could be priced in the top 3 subnets, which means you're earning more than 5% of the overall network emission based on the current range of subnets and their dominance. That is a very significant amount of emission. That's tens of millions of dollars per year, if not close to $50+ million per year in Tao emission that you earn from your subnet. But to your point, Templar is not revenue generating. It's just creating this permissionless training network for developers to train their models. What Templar does at a technical level is they're basically creating infrastructure that allows a distributed group of computers, a decentralized group of computers, to actually produce the weights and produce the intelligence when you train a model from scratch. When you're training it from scratch, from nothing. You could take a base model and maybe train against that, or train against a brand new data set. That's what Templar is doing. And this is actually currently not economically valuable because the level of capability of models that they're producing is still very inferior to, even maybe the top 20 open weights models. But what's interesting is that if they can get Templar's distributed training network to actually work at a large scale of tens of thousands of computers or hundreds of thousands of computers or millions of computers, right? Like where Elon wants to be in a year or 2 years, right? But they can do that permissionlessly over the internet because the incentives are aligned properly. If their infrastructure for training Templar and basically producing the weights, producing the parameter space for the models that they train allows for using distributed groups of GPUs across the internet in many data centers with very heterogeneous networking characteristics, right? Like very, very complex to do. But if they can arrange their mining incentive and infrastructure properly to prove that they can build models and train models on Templar into the multi-trillion parameter regime, like many trillions of parameter models, and they can get to models that are 10 trillion and 20 trillion parameters. This surpasses the scale of the largest state-of-the-art centralized labs, which vertically integrate everything. They vertically integrate data acquisition, labeling, cleansing, fine-tuning, training, inferencing, selling you the model. They vertically integrate the whole thing. right? And they do that because they want control over the entire stack. What Templar says is, we're going to commoditize the training part so that anyone on the internet, if you want to train a mini God model for James, where you give it all of your personal data going back 20 years, and that's too much data to train on gradients or on one of these proprietary AI labs. But wait a minute, Templar is serving up a multi-trillion parameter training run for you to join and subscribe to. They could monetize that. And if they monetize that correctly, that could be extremely profitable. And then they could buy the alpha token from the profits and basically produce a very valuable subnet on Bittensor.
I didn't know that. I always thought of Templar as like almost like a hobbyist thing. But to your point, it's infinitely scalable, so it could potentially reach the right now it's like something like 70 billion parameters, but it could reach, because it's so scalable, the 70 trillion parameter level. So maybe you're saying the miners are incentivized because they think that there is, even if there's a 1% chance of that happening, it's still worth it to them to mine on Templar to help do this, run this software, run these GPUs and so on, and get these alpha tokens.
And coordinate. And what you measure as the objective function for Templar is the smoothness of the loss function, the error rate, right? So the loss is what you look at when you're optimizing how well a training run is doing. Like in the middle of the training run, right? You want to make sure all the loss is minimized as smoothly as possible, ideally as fast as possible. But in most cases, it's so much data to actually, imbue and transform into the weights of a neural network that it happens more gradually. The more smooth the loss and the convergence of the loss, the better. And so what miners on Templar are rewarded to do is to optimize the smoothness of the curve of the loss when they're basically connecting thousands or tens of thousands of GPUs around the internet to train a neural network. That is extremely hard to do, because even in a centralized data center like Elon's in Tennessee, for example, I was talking about last week, that's also very hard. In one building, like in one Costco-sized building, where you have racks and racks and racks of the GPUs, it's hard to do training runs even in that environment, because you have GPUs blowing up. You have a GPU in the corner that just exploded. You have like a rat ate some of the cable on row 76, and that disconnected the weights of the sharing of the gradients. And so that fucked up like that part of the neural network, right? Like now we're talking about doing this across 40 countries, 100 countries, different types of hardware, different types of compute, operating system firmware, different types of networking characteristics and speeds at which the data is shared across those computers. Oh my God. So when we talk about having successfully trained a functional, not horribly performant, actually fairly performant LLM in a billion parameter regime, even though when you say, wow, it's only 1 billion parameters, this is extremely impressive for multiple reasons.
Where do they get the data from in Templar?
Yeah, they just use a publicly available data set, and the miners are rewarded for training the model successfully across all of this distributed hardware. Right now, you're not going to go walk up to Templar and be like, oh, this is cool, I'm going to train a James model on Templar. You're not going to do that. Right now, their sole focus as Templar, which they're very serious, by the way, and the guy that runs it, I know him, he's a really talented guy. Their sole focus is to prove that the incentive mechanism on Subnet 3 Templar is good enough to scale the distributed training, permissionless distributed decentralized training of models from the 1 billion parameter regime to 10 to 50 to 100 to a trillion. And I think that the trajectory is that they are going to scale across that. And you'll be able to see something that's extremely disruptive to the centralized labs. One thing that I want to say that Jensen actually said in an interview some months back, I tweeted it out. He said, perhaps one of the most important breakthroughs we're going to need to see to be able to scale AI across these bigger and bigger thresholds is distributed decentralized training. He literally said that in the interview. And what that means is, in order to actually harness the necessary computational power to train the models that we believe will be AGI or ASI or whatever, we may need to chain and integrate many distributed data centers together as opposed to doing it just in one big data center, right? And so in order to do that, we have to have these decentralized training technologies. What's interesting is Google is already doing this internally, and they've publicly talked about this. Demis and Sundar have talked about this publicly, which is they have many Google data centers across the planet, and they interconnect them, and they do training runs, cross data center neural network training runs. That's very cool. There's very few companies in the world that can do that. Actually, I'm pretty damn sure Google is like one of the only companies in the world that can do that at that scale. Why is it possible for them to do that at that scale? Their entire infrastructure stack, from the concrete of the data centers that they build all the way up to the server chip design, the rack, the networking gear, everything, it's all homogeneous. It's all homogeneous. It's all the same. They have the same chip design. They have the same rack design. They have the same networking interconnect protocols. They have the same storage subsystems. They have the same firmware. They have the same everything, all homogeneous. They have the same operating system kernel running. They have their own specific programming languages that they optimize to send the code around. They have the same architectures. They have the same everything. When you look at all of those different ingredients, those different layers of technology, and then you look at the real world, right? Like the internet, it's not all homogeneous. It's all heterogeneous or heterogeneous, depending on how you pronounce that.
Yeah, I never could
Heterogeneous,
figure that out.
meaning it's all different. It's all different, right? So exponentially increases the complexity of coordinating all of the data and all of the computation. Exponentially increases the complexity. So we'll see. I think Subnet 3 Templar is a great team. They're very talented. They're very driven. They have a lot of aggressive miners that are like really pushing hard to make this work. I think we're going to see categories of training subnets in the same way that we have labs competing against each other using all these different techniques. And we also have diversity of competition at the large cloud provider level, right? We have Azure, AWS, GCP. Those are the three big ones. I think we'll probably have 3 decentralized training subnets on Bittensor that are each successful in their own ways, that are interesting and different, and they'll each be very valuable and probably in the top 10 or top 20. Our jobs as Tao holders and Tao allocators is to study, learn, follow, and be patient to find the teams that will ultimately be the top 3 in that category. And then also be intellectually humble and intellectually honest with ourselves about perhaps there's going to be new disruptions and new technologies that replace the way training works today. For example, we are not going through a pre-training process right now. We're talking to each other over the internet. We're having this conversation. We planned ahead of time. We've been really looking forward to it. We're doing it now. We have to hydrate. We're going to get a meal after this probably. We'll end the day. We'll watch a movie tonight. We'll go to bed, whatever, right? Our brains are not going through a static pre-training phase that produces the weights, and then we inference them, and then you like destroy those weights and you train some new weights, right? Because we just need a whole new brain. No, we grew our brain, right? And then we create new connections within our brain that we have grown on our head, but it's continuously learning throughout our entire life. New AI models will likely be similar, and we're going to change the way these AI models are built from being pre-trained to no more pre-training. There's no more training anymore. They will be continuously learning. They will be continuously learning across their experience. And something that I think people need to learn about and read is a paper written by David Silver and Richard Sutton. It's called The Age of Experience, which is this new era, this new age that we're moving into. And Bittensor is the absolute perfect platform for the age of experience. Why? Because Bittensor incentive mechanisms are designed to be continuously evolving and continuously incentivized across their existence, right? So if you have a new neural network architecture that came along, you can just modify the incentive mechanism to say, we want to reward that particular type of architecture. And the network should go and evolve and take shape towards optimizing and incentivizing that particular architecture. And also, the thing about the incentives that are recorded across all of the miner activity on Bittensor's network, that is a infinite time series of data. It's sort of like an infinite journal or transaction history of all of the intelligence and the weights that get propagated. And so Bittensor itself is kind of like a continuously learning AI that is propagating these incentives across all of these subnets. And the moment we have an evolutionary breakthrough in the way that transformers or other architectures of these AI models are built, that will be incentivized beautifully on Bittensor. And the age of experience could actually produce, this kind of ASI or AGI that everyone's looking for. I personally believe that's where we're headed. And so pre-training subnets, they'll need to evolve. They'll need to evolve to sort of accommodate to that new reality, if that makes sense.
Yeah, and it's so interesting that you quoted Jensen Huang's quote that we need distributed, because he must realize, he knows very well that he's probably tapped out. Like, he can't produce more GPUs, and more GPUs are needed. And I can't just go to NVIDIA and buy a GPU. Like, they've run out every year. So he probably realizes that AI is capped unless there's some infinitely scalable way to do that. And the only way to do that is through decentralized, through distributed. And that's exactly what Bittensor offers.
If I'm Jensen, I want to push back on two things. And I want to slow the rate of improvement and potential of two things: open source and decentralized. Those two things I want to slow down. Open source hurts his stock price because CUDA is the monopoly for NVIDIA. CUDA is the programming language, is the parallel programming language for all of their chips and all of their programming toolchain. CUDA is a proprietary black hole that no one has been able to figure out how to crack after tens of billions of dollars in investment. I think that needs to change, and it's very difficult. And again, NVIDIA, Jensen has a monopoly on most of that talent in the CUDA kernel ecosystem. The second thing he wants to push back on is decentralization. Why would I want to create a supply glut when there's supply scarcity? And because of that, I sell out instantaneously, and my stock price is going into the tens of trillions of dollars probably, right?
Unless decentralized means more NVIDIA chips are sold because everybody wants to be a miner.
Where do you get the money? Where do you get the money to buy them?
That's why NVIDIA is tapped out. Like, that's why they can't grow. I mean, they're already growing incredibly fast, but they can't grow faster because there's only so many chips they can make. And they're making billions and they're spending billions.
I did a calculation on the power consumption needs to just run all of the NVIDIA chips that Jensen is going to ship in the next 18 months. Just to run that is about 100 gigawatts of power. 100 gigawatts of power. The United States currently runs on 500 gigawatts of power. The entire United States, the whole country. Okay, just so people can conceptualize what this number means. In the United States, we are building 0 nuclear reactors. China is building 130 nuclear reactors, which will be online over the next decade. We're building none. Each nuclear reactor is 1 gigawatt. Each nuclear reactor is 1 gigawatt. So it's 130 gigawatts of power that China is bringing online in the next 10 years, decade. Okay. NVIDIA's GPUs will require 100 gigawatts of power to run them all, just to turn them on and run them full time between now and the end of 26, based on analyst estimates of the numbers of chips they're going to sell. We do not have availability of power in America to run the NVIDIA chips. We do not have the availability of power. We would need to accelerate solar, thermal, wind, and nuclear, which is currently strangulated by regulatory friction, in order to just be able to run those chips. This is pretty crazy. And so I was thinking the other day, I think this is a good idea. I think someone should do it. Maybe we'll do it. Is we should create a Bittensor subnet or a category of them and experiment with like 5 strategies in parallel, different approaches to reward people to produce renewable power and renewable energy by basically going and saying, you build a small modular nuclear reactor, an SMR, right? You will get a certain amount of emission from the subnet. If you lay down certain size of field of a farm of solar with producing this amount of output that we can verify using IoT devices, maybe, you'll get this amount of alpha token from the subnet. And then we can permissionlessly incentivize the continuous production and improvement of renewable power for the world. And then you can say, oh, I have a Bittensor subnet, or there's like 3 or 4 of them that are producing free renewable power. I can plug that in. To my training subnet and my compute subnet. And something like what you were saying earlier on how do you integrate these subnets? You're gonna have an ecosystem of subnets that all integrate and cooperate with each other and basically provide the foundational sort of like tapestry of commodities that allow you to build a really powerful product or platform of some kind.
And look, I think this is the beauty of Bittensor, that what you just did is you just redefined the whole carbon credit system.
Yes.
So basically you just recreated clean energy, or so-called clean energy, without having to pass a law. And this is the beauty of real, I'm going to again use the word incentivism instead of capitalism. This is the beauty of incentivism, is that if everything's driven by incentives, and as opposed to regulated capitalism,
Bingo.
and then you win. And that's what Bittensor does. That's what Bittensor is a microcosm of now, but hopefully it'll be a macrocosm of it. So look, on that, I have to absorb everything I learned. Like, Joe, I always learn so much. You have so much knowledge about all this stuff. So great episode. And what are we going to talk about next week? We're always going to think of something new, because
there's going to be new things. There's going to be new things.
It's an infinite deep dive, like
Yes.
into what Bittensor offers. So
I learned a lot as well. Every time I talk with you, James, I learned so much, and I'm really excited to do this. And I think a lot of people are going to enjoy it as well. So I can't wait to do the next episode myself.
Excellent. Well, see you next week.
Sounds good.